All after school activities are canceled.
I knew that was gonna happen.
Yep. What's up? Yeah, put it over there. Now we've squandered all this time. Well, we have to stop at 25? Like, damn. Okay, good. No, we have 15. We have 15. All right.
Yeah.
What's up? What?
Wait, where is it?
I did already. No, over here. Always over here. Doesn't matter. I don't care where. Let's do one of these. All right, we're gonna have what? Wait. No squandering time. Sit down, immediately begin exciting, engaging activity, which is already on your desks. The directions are go. Help each other. What? All right, everybody has this important skill. And we're going to spend exactly 5 minutes on this, no more. The important skill is sketching derivatives. What I have given you are some functions. And what you are supposed to do is, using your intuitive knowledge of what derivatives are, draw the derivative of these functions. And if you read the directions a little bit more carefully, it says, get out your class mandated supply of colored pencils. And first in pencil, you're going to graph the derivative of the function. Actually, let's just do that for now. Just graph the derivative of these functions. And when you're sure that you're right, and by that I mean everyone at your table agrees, then go over it in blue. All right. And yeah, just start. Go.
Wait,
What you are to be more specific, what you are doing is you are graphing the function which outputs the derivative at any given point. And this is about the whole year, the worst time. I know I said first make sure it's right. And this is not an algebra activity, so you're not supposed to be trying to figure out what that function is and then using derivative rules. You're just supposed to be go for it with approximations.
Wait, what? Wait, what is happening? Just draw it? It's probably going to just be the same.
Okay, whatever. For that one's fine. The other one. But what you're meant to do. Okay, so for example. At x equals 2, what's the derivative? Derivative is a number. Yeah, exactly. Yeah, so what you should be doing is you should be getting out a pencil. And you should be, yeah. Maybe. You should be, and you should be kind of following a pencil along and seeing if, so look, for example, at x equals 3, is that the slope of 1 to you? It's bigger than 1 to me, right? So maybe at x equals 4, according to you, the slope is 2. That slope looks way more than 2, isn't it? Yeah, you need to kind of you sort of plot some points. All right, I know, that's why you got to help each other. So talk to me. Yeah, but that's sort of, maybe, but that's sort of irrelevant. So let's go through, pretty much. At x equals 2, for example, what's the derivative? 0, yeah. Thus, you should put a point at 0. Derivative at 2 is 0.
Oh!
Yep, you can be totally wrong. Put your pencil at the point 3, 2.
No, not
put your pencil, make a tangent line at 3, 2. What does that slope look like to you, roughly speaking? Oh yeah, Arun's gonna help people also.
2.
Looks like about 2, yeah, I agree. Thus, the derivative at x equals 3 is 2. So put a dot at 2.
Oh, so it's 2x from the
Well, what's the slope?
Before you said no.
2. Okay, so forget about the algebra. We're just applying points. So for example, when x is 2, what's the derivative?
I don't know. That's why I'm asking.
So it has a
Everybody
Yeah.
Put your pencil at the point.
How are you-
So there's like pencil next to pencil is at the point. One is one on the station.
Well, it's 0 at negative
If it's here, just put a pencil there.
Yeah, I just did it. I'm just trying to. Wait.
Negative 2.
And then they go up to a
That's 1. So we have to like.
Very limited, not very limited.
Yeah, there's like no difference. The color pencils are ugly. Yeah. No, I really liked markers when I was a kid. I didn't like color pencils. I like the crayon. It makes these more worse. Crayons is the worst. It's like little ears on the way.
Let's just do the first part. Let's just do one derivative. Yeah, so work together.
I get it now.
Is this happening? Is this happening?
Is it a positive or a negative?
Yeah, good.
Negative 1, yeah.
We are working on this worksheet called Sketching Derivatives.
One
How
time.
do you do this? How do you find what the derivative of like from right and put like -5? Yes. Wait, how do I do this? How do I do this?
This table had some derivative mistakes.
That might not exist.
Take the point 1, comma 2. Okay? What is the slope of the tangent line to the curve at 1, comma 2, roughly, in your opinion?
Slope right here.
Thus, the derivative at x equals 1 is -2,
Okay.
according to you.
That's what it should be.
Here it's like,
Wait, so what
It should just be like that.
Yeah.
Yeah, I was like, why is there a line? Wait, what? Why?
Because when you go this way, it's like,
you can draw
yeah,
it
right now, and it gets
Wait, why is there only one line?
Because where did you get that? Where's the only here, the tangent line is drawn here.
Okay, you already drew it.
Like there can only be one. It's
so terrible.
It's or negative. Yeah, it's a parameter. Yeah, I do that. Even 10 we don't know that. We have 2 roots and we have
Over here, negative. But it's rising. Slope is this.
Make this go up and graph.
I don't know. The general gist though is good. Yeah, and here it's going to be 0. It's going to be 0 like that's like 1.
Actually, we don't have. You know how to like
Alright, get everything you need to get out of this in the next minute, and we're going to do something really quick.
How did you figure this out? Like, I don't get it.
I think it just looks like this.
Yeah, it looks like that.
Yeah, it's like purchase 0.
1, 2, 3, 4, 5, 6,
Oh, okay. I think it looks like this.
a line sort of like that.
Alright, time to learn something new. Are you ready? This is a bold and amazing moment in your life. Yeah. Every day, Cash. That's ridiculous. You guys are so lucky. You have no idea. Alright, Arun, we will now make a graph of the sine function. Ready? And I'm going to do this in such a way that respects the actual dimensions of the sine function, And so if the function always lies between -1 and 1, I am going to make sure to put my pi such that that looks about 3 times that. Does it? Decent, right? So real sine, never mind what you've seen, you know, textbooks and stuff. Real sine looks like this.
Oh, not like.
Should we be taking notes? I don't know, probably. All right, so there's sine. And now what we're going to do is we are going to harness our derivative sketching skills that we learned 1 minute ago to sketch what we think the derivative of this function should be. All right, Ethan, what do we think the derivative of sine is at x equals 0?
I mean,
We have to wrap up this lecture in like the next 3 minutes.
you think that
Ethan.
the derivative is
Give me an answer.
like
Eustace.
1.
Eustace says 1. Eustace, why?
Looks like it's going up.
Arun, can you tell if there's important people outside, you can tell them to come in and set up their presentation, but if it's just like random kids, tell them they're going to wait 4 minutes. So wait, why do you think the slope is 1?
Looks like 1.
It looks like 1. It does look like 1. Can we check to see if that's true?
Sure.
Let's let the function f of x be sine x, and using the definition of the derivative, please tell me what f prime of 0 is. You guys got this? Okay, we'll go fast, because the derivative at 0 must be the limit, as x goes to 0, of sine of x minus sine of 0 over x minus 0. Is that what you were doing? Hopefully it was. And what is sine of 0?
0.
So this turns into the limit as x goes to 0 of sine x over x, which is?
1.
Which is 1. All right, that means that Eustace was right. The derivative really is 1 at x equals 0. So let's put a dot there. All right, now what is the derivative at pi over 2? Steven?
0.
It's definitely 0. Okay. What's the derivative at pi? Whoa. What the hell is happening here? What's the derivative at 3 pi over 2?
0.
0. What's the derivative at 2 pi? 1. Holy crap. No, it couldn't possibly be true. The derivative of sine is cosine? Unimaginable.
I don't like that load as
All right. Let's do it. We got 3 minutes. Let's figure out what is the derivative of sine x. Go. Someone start me off. Sandeep, start me off.
So do the limit as x goes to 0.
H goes to 0.
0 of f of x plus h minus h, or yeah, minus h, or minus f of x over h.
Yep. Okay, go. Now, what can we do? There's only one thing to do. Yeah, Emma says split it up, yeah. This is going to be the limit, h goes to 0 of, someone give it to me? Yeah, sine x cosine h plus cosine x sine h minus sine x all over h.
Yes.
Oh man, what do I do now? You did a problem that was very, very similar to this. Ethan, tell me what to do.
Oh wait, so like sine x times cosine h is just sine x because cosine of 0 is 1.
Okay, I'll just tell you what, yeah, that's
and
right.
you get
So
this.
we're going to split this up into sine x times cosine h minus 1 over h. See what I did there?
Yeah.
Plus the limit as h goes to 0 of cosine x sine h over h. In other words, what it is, I collected the first and third term and factored out a cosine. You guys with me?
Yeah.
Sorry, it's a little bit rushed. All right, last step.
It's basically like
This limit is in h's, so I can just take out the sine because that has nothing to do with h's. So this is sine x times the limit as h goes to 0 of cosine h minus 1 over h. And over here I can just take out the cosine. What's this limit?
0.
That limit is, as previously memorized, 0. And this is cosine x times, what's that limit?
1.
1. Holy crap. Don't tell anyone any of the other periods. The derivative of sine is cosine. Pack up your stuff. Do it silently as I tell you where you're going. Ready? I'm going to say one's name only once. You can turn that off.